Hello, hello. Today I've been doing complex numbers again. It's very hard. I don't know why. Two. Okay. I might do more questions. Might just do these two and move on to science a bit, or I might do another one because I don't like this topic, so I should do more of it. Ooh. Okay. Um. So let's start with the first question. It says expand cost. Wait. Expand cos 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 theta plus I sine theta or 5. Okay, so it's just normal expanding as there's sections to this question, so it should just be normal expanding. And that just means this will become, okay, so cos theta plus I sine theta should just, 5 with a 1, 5, 10, 10, 5, 1 from our Pascal's triangle, and that'll be cos 5 theta plus 5 cos 4 theta sine theta I plus, I should move this to another line. Oh, move that here. So that becomes 10 cos, well, that becomes negative. So that becomes 3 theta sine theta as the I become I squared becomes negative 1. Okay. And there's another 10, so we do plus 10. Well, that becomes negative I, so still negative. There's cos squared theta. Well, that should be squared. Sine to the power 3 theta I. And then we have to plus 5 cos theta sine 4 theta as the I become 4 and becomes 1, and then that becomes I to the power 5, which is just I again because it's one rotation, so you plus sine to the power of 5 theta I. Well, that's very long, and that's it for the part A of this question. It shows how hard the other one's gonna come. Okay, actually not that bad. And it says by Mulver's, okay, the Mauve, yeah, by the Mauve's theorem, we know that cis to the power 5 is cis 5 theta. Use this result and the result of A to show that cos 5 theta equals to 16. Okay, yeah. So they want us to start from the left side. So first we have to write cos 5 theta. What does that become? So first, that just equals to, well, becomes this add I sine 5 theta will become cis 5 theta. And cis 5 theta is just cis theta 5, which equals to this thing. So that means that cos 5 theta should just equal to that thing, this thing. Okay, so we just write, okay, cos theta plus I sine theta power of 5 minus I sine 5 theta. But we know that cos 5 theta have no imaginary part, so the right hand side must not have an imaginary part as well. So what we can do is we can do the left hand side, which is equal to cos 5 theta equals to, we can just say that equals, because this part will not be there anymore because it's I, we just leave left with this part with all the components inside that don't have an I inside, so that just becomes cos 5 theta, take 10 cos 3 theta sine sine squared theta plus 5 cos theta sine 4 theta. Yes, and I haven't told you the equation. I have the actual question. So it says cos 5 theta equals 16 cos to the power of 5 theta minus 20 cos to the power of 3 theta plus 5 cos theta. Which is stupid. Okay, yeah, that's a very long question. That's why I didn't write it. I mean, normally we would just, this would be the working out. You'd be staring at the question, so you have to write the question again. I should. You know what? Sure. I don't care. Yeah. Okay, it's fine. We'll get to the answer anyways. And that was equal to cos 5 theta. And that's it. That's an equation, so we have to change it. So then we have to change the rest of it, which is 10. The cos stays the same because we want to keep all the causes. The sine becomes 1 minus cos squared theta plus 5 cos theta, and that will become 1 minus cos squared theta, but you square it because it's to the power of 4, and that becomes cos 5 theta minus 10 cos 3 theta plus 10 cos squared theta plus 5 cos theta 1 minus 2 cos squared theta plus cos to the power of 4 theta, and that becomes, well, these two can, wait, no, that's wrong, that should be 5. I was like, what? Okay, yeah, no, these two can be combined together. I was like, that's not the answer. Okay, 11 cos 5 theta, as we're proving, where I know what we want to get to. That's weird. Okay, then that just become, take 10 to cos to the power of 3 theta plus 5 cos theta minus 10 cos to the power of 3 theta plus 5 cos to the power of 5 theta, and that becomes 16 cos to the power of 5 theta minus 20 cos to the power of 3 theta. Oh, that's it, plus 5 cos theta, which equals the right hand side. Is it? Yep. 16, take 20, plus 5. Yep, I'm right. Okay, now that's part B, but that's the first part of part B, and there's a second part of part B. And so that this one is want us to prove. You know what? I'll write it this time. Want us to prove sine 5 theta over sine theta equals 16 cos 4 theta minus 12 cos squared theta plus 1, and then I did say that sine not 0 because it's on the bottom. Okay, that's not important at all. So then now what we have to do is to expand the top. So so this is the imaginary part of the equation we had. So how do we do that? So basically what we have to do is we say that sine 5 theta equals, or the imaginary part of the long equation we had, which is here. So just copy that. It's very long. Okay. So this we want. This we want. And this we want. The rest we don't want. Alright. Alright. But we don't want the eyes because we're already counting the imaginary part, and that means sine 5 theta over sine theta will equal to, let's just write that here. That's the left hand side, and that equals to 5. We can just do it in our brains because why not? Minus 10 cos squared theta sine squared theta plus sine 4 theta. And then it's basically the same as the last one, so it's 5 cos 4 theta minus 10 cos 3 theta, 1 minus cos squared theta, plus 1 minus cos squared theta, power of 2, and that becomes 5 cos 4 theta minus 10 cos 3 theta plus 10 cos 5 theta plus 1 minus 2 cos squared theta plus cos 4 theta. And is that right? Yeah, yes, I think it is. I think it should be right. Why do we have so many different numbers? Huh. Cos to the power of 4. This should be 4. I don't see how that become. Yeah, I copied it wrong. I was like, what? It's like, how do we solve that? Okay, that just 16 cos 4 theta, as there's one right here, and then that we take 12 cos squared theta plus 1. And that is exactly the answer we want. Yes, and equals the right hand side, and that's done for this question. Then now we'll move on to the second question that have like 8 parts, 7 parts actually. So this question, part A, says let W equals 2 cis theta and Z equals W plus 1 over W. And that just, and I was to find Z in terms of theta. So what we can do is Z just equals 2 cis theta plus 2 cis theta but to power negative 1. So then Z will equal to 2 cis theta plus a half cis negative theta. And that just equals to 2 cos theta plus 2I sine theta plus well, that's negative theta for cos. Negative theta for cos. Wait, negative theta for cos is just theta. So what we can do is we can just write a half cos theta, and then for the sine it'll be negative because negative theta for sine is negative. I sine theta. And of that should, and then we can combine them, and that just makes it so that's 5 over 2 cos theta plus 3 over 2 I sine theta. Yep, that's it for the part 1. Part 2 says show that Z lies on an ellipse with equation x squared y squared, oh wait, x squared over 25 plus y squared over 9 equals 1 over 4. And we can see 25. Oh, that's 5 squared. 9. Oh, that's 3 squared. That looks not like a 3. Okay. So basically, we have to set x as 5 over 2 cos theta. And if we think of this on the Argand plane, there's actually no I. I is just the y value. So y just equals to 3 over 2 sine theta. And then that just means the left-hand side, which equals to x squared 25 plus y squared over 9 equals, and that just equals to, well, that's 25x squared over 100 plus 9y, oh, that should be sine squared, that should be cos squared over, well, that becomes 4 times 9, 36. So that just equals to 1 over 4 cos squared theta plus 1 over 4 sine squared theta, and that just equals to 1 over 4 cos squared theta plus sine squared theta, which equals to 1 over 4, which equals the right hand side, and we've proven it. And for part 3 of this question, it says show that z minus 2 squared equals to 5 over 2 minus 2 cos theta, and then everything squared. That's weird, so we have to show z minus 2 squared equals 5 over 2 minus 2 cos theta squared. Okay, so we first say that z minus 2 is just equal to z, which is stated right here. But 2 is the real part of this equation, so that's just 5 over 2 cos theta, I think. Negative minus 2 plus I sine theta. 3 over 2. 3 over 2. I sine theta. Yes, okay. And then we have to square everything. So we just have to square each of them. So z minus 2 squared equals to 5 over 2 cos theta minus 2 squared plus 3 over 2 I sine theta squared. And to do that, that just becomes, well, that becomes 25 over 4 cos squared theta minus 5. Actually, that becomes 10 cos theta plus 4 plus 9 over 4 I sine, well, it doesn't become I anymore, it becomes negative theta, and that, oh, it should be squared, that just makes it so that that becomes 25 over 4 cos squared theta minus 10 cos theta plus 4 minus 4 over 9, and that just becomes, well, that's just 1 over 1 minus cos squared theta, and that just becomes that plus 9 over 4 cos squared theta. If you simplify that, you add those together, that just becomes 30. Ooh, does that become 34? Yes, it does become 34. But that's not right. That's not right. If you negative that, well, where did the negative come from? Oh, well, it came from the I squared. But the I squared shouldn't be here because there shouldn't be any I. Yes. Yeah, no, that shouldn't be I here. Because we're doing, well, then it should be an I there. I squared is negative. And if you square, if you square that, becomes negative, and then it becomes this thing. That's not right, because that won't then that won't become one. That won't become whatever that thing inside the brackets is. Then we just, this should be a plus. Well, if that's a plus, that's a negative, and then that just becomes, well, that just becomes 4 cos squared theta minus 10 cos squared, and that becomes 16, and 16 plus 9 is 25 over 4. And basically, then if that's the case, then it should just, we can make that into 2 cos theta minus, well, no, because 2 cos theta is the maximum, well, it should be 5 over 2. If you time those together, it does make 10. I mean, times 2 again. But that's not possible because this is 2.5. This, the maximum is 2. This should become negative, but it have an absolute value at the front, so it must be 5 over 2 minus 2 cos theta. squared, and that's exactly the answer right here. Yes, okay. And now we move on to the final part of the part A of this question. We have to show that z minus 2 plus z plus 2 equals 5. And z plus, so the left hand side just equals to, well, 5 over, are they squared? They're not squared. So then z minus 2 squared, and then you square root it, and that just equals, okay, plus z plus 2, that just equals to 5 over 2 minus 2 cos theta. And for z plus 2, it's actually just changing this into a plus. If this becomes a plus, becomes plus 10, plus 10, plus 10, plus. So then that just becomes 5 over 2 plus 2 cos theta. And that becomes 5 over 2 plus 5 over 2, and that just becomes 5 and equals the right hand side. Yeah, that's it for this question. So I'm not sure why I squared doesn't become. I don't think you use the I here. That's a thing. That's a problem. Oh, well, that's it for the part A of this question. Part B is similar but different. So basically, it says, let W, this time let W be 2I cis theta, and Z equals the same, and I find Z in terms of this thing. So then Z just equals to 2I cis theta and a minus 1 over 2I cis negative theta, and that just equals to 2I cos theta plus, or it becomes minus because it's I squared 2 sine theta, because it's originally I sine, and that should minus, well, cos stays the same sign, so then that should just be negative, which should be 1 over 2, because normally it can just, 1 just becomes negative I squared, and squares cancel out, and it just becomes negative a half. Negative a half, well, then it becomes plus I cos theta. And then for the sine, it should be negative, but sine made it positive, but I want to take I out, that becomes negative a half I sine theta. The I should not be there, actually. No, the i's cancel out, so just p plus a half, and that makes us 5 over 2I cos theta minus 3 over 2 sine theta, and that's good. And then for part 2 of this, we have to show that z is in the eclipse again, so let y equals 5 over 2 now, because that's on the imaginary axis, so 5 over 2 cos theta, and x equals 3 over 2 sine theta, and then y squared plus 25, x squared 9 equals, well, that's just 1 over 4 cos squared theta plus, that's 9, it becomes a fourth as well, a fourth sine squared theta. Although that is negative, I think, because you square it, becomes nothing anyways, and that just becomes 1 over 4. Well, then that's left hand side equals right hand side. That's it for this question. And for part 3 of this question, it says show that this thing again. So basically it's z minus 2I plus z plus 2I equals 5. Okay, so z minus 2I, that should just equal to, well, if we square, that will literally become the same as this. So basically it'll become, where did it go? Where did it go? It become this thing. Let's just copy that. It become this thing but squared, but you want -2 on the other side. Low power mode. Oh my god. -2 squared. This you square as well. That becomes 25/4. Will be negative, but apparently it's not negative. And then let's just put it in fast. Let's see. And then it'll be -9/4 sine squared theta plus, it'll be negative, but then you negative on the outside, so then it becomes a plus. Yes, if it becomes a plus, it becomes you times 2. It'll be 6 sine theta plus 4, but then you minus 4, and that basically becomes that becomes so basically, okay, I had to talk to my dad. Okay, yeah, continuing. Battery's running out. Continuing the signs. Where am I up to? Okay, I have to convert them into. I think I have to continue doing convert them into. Wait, what do I have to do? I have to convert them into causes. 4 cos. That should be squared. Theta minus 9/4. That should be, yep, that's right. Now I'll convert the cos into sine. That'd be 1 minus, that'd be plus 25/4 sine squared theta. Squared theta plus 6 sine theta minus 4. That basically becomes, if I minus it, yeah, no, I think that's not right. So we have to do the thing. I don't know why it works like that, actually. I'll figure it out later. So then that just becomes actually it should be plus. Okay, yeah. That becomes 4 sine squared theta plus 6 sine theta minus, well, that's 16. 16, if you plus, it will become 51. Wait, let me check. Let me check this. It should. That is really weird. If I minus 2, should be 25/4. Not sure where the 4 came from, because that becomes 1/1 minus. All right. Should be 4, 6, and it should be 25/4. Not sure how they got that, but that's that. I'm really confused by this question. I'll figure it out later. Yeah. So then that just becomes, that makes it so that z minus 2i equals negative 2 cos. Wait, where did the cos come from? That is so weird. You know what? This question is weird. I'm not even gonna do it anymore. I think this question is given wrong. I'll check it later. Oh well, bye bye.